In this lesson we're going to be solving quadratic equations, and I want to show you an example of what a quadratic equation looks like on a graph and what that solution looks like before we get started in solving actual equations. If you'll recall from our graphing unit, you'll remember that a quadratic equation is parabola on the graph, or it looks like a U. And so our first statement here just kind of defines what we're doing today. We've got the equation x squared minus 4 is equal to 0 is what we call a quadratic equation. And its related quadratic function is y equals x squared minus 4. The solutions of a quadratic equation and the x-intercepts are the same. So if we were going to graph our quadratic equation, we could draw a t-chart where we use our x values of, we could do -3, -2, -1, 0, 1, 2, 3. So plugging these into our quadratic function is y equals x squared minus 4. We'll just do this quickly since we're not going to spend a lot of time on graphing today. If we take -3 and plug this in for x, that would give us a +9 minus 4 is 5. -2 squared would be 4 minus 4 is 0. -1 squared is +1 minus 4 is -3. 0 squared is 0 minus 4 would be -4. And then the same thing with 1. We would get -3 when we squared it and subtracted. 2 squared is 4, 4 minus 4 is 0, and then 3 squared is 9, 9 minus 4 is 5. So these would be our points we're going to plot. We have -3, 5, -2, 0, -1, -3, 0, 4, and then our positive values are in the same place. And so this has created our parabola. If we connect these points, we'll see that we do have a U shape. Okay, now the solutions are our x-intercepts on the graph. So if we look at where our parabola crosses the x-axis, we can see that one of our x-intercepts is -2, and the other x-intercept is at +2. So this would be the solution to our quadratic function, -2 and +2. It's also going to be the same for our quadratic equation here, -2 and +2. And what we're going to focus on today is, rather than graphing all of these to find the solutions, we're actually going to solve these using algebra. So let's take a look at an example of that. This won't be our first example. We're going to take this same problem and solve using square roots. So I'm going to solve this equation like I normally would. We're trying to isolate the variable. So we add 4 on both sides. That gives us an x squared is equal to 4. Now I'm going to have to take the square root, and square rooting my x squared is going to make the squared and the square root cancel. That leaves me with just an x. And when I square root my 4 here, I'm going to get 2. Now we're all used to saying the square root of 4 is 2, but if you think about it, if I say 2 squared is 4, I also have another option if I square a -2. -2 times -2 is also 4. So we're going to introduce a new symbol today, plus or minus. X is going to be equal to +2, as we see here, or x can be equal to -2, as we see here. So when you take the square root today, it will be plus or minus your answer. So we have x equals plus or minus 2, and as you can see in our graph, it's the same thing that we got here when we graphed it, a -2 and a +2 at our x-intercepts. Let's move to our official example 1. We are going to be solving 3x squared equals 300. So we're isolating our variable. Divide by 3. and we will have x squared is equal to 100. The next step, since x is almost isolated, we have to get rid of this squared exponent. So we're going to do the opposite and square root it. That will give me an x. I'll have to do the same thing to 100. The square root of 100 is 10, but that could have been 10 times 10 or negative 10 times negative 10. So x can be positive 10 or x could be negative 10. And this will be my answer. Very simple today. Example 2 is done essentially the same way. We're going to isolate our variable. So we're going to move this 980 first. I'll add that to the other side. And I'll have 5x squared is equal to 980. The next step will be to divide both sides by 5. Dividing both sides by 5 will give us 196. The last step is to take the square root of x squared and the square root of 196. That makes our squared and the square root disappear for our x. And the square root of 196 is 14. It can be positive 14 or it can be negative 14. And what these numbers are telling me, our first one for example 1 and our answer for example 2, this is telling me where on the graph, if I were to graph these equations, I would see the parabola intersect the x-axis. So for example 2, we would see our parabola intersect the x-axis at positive 14 and at negative 14. Sometimes we're going to run into problems that we see in example 3. To isolate the variable, we add 4 first, and we'll have 4x squared is equal to negative 16, and then divide both sides by 4, and we'll be left with x squared is equal to negative 4x. Now the problem comes when I try to take the square root of both sides. We've talked about this before in solving absolute value equations. When you have an absolute value equation, you cannot have the absolute value equal a negative, and it's the same thing for square roots. You cannot have an answer when there is a negative number underneath the square root. That's what we call an imaginary number, and today we're focusing on real numbers, so we want to have a real solution. And since I have a negative 4 underneath the square root, that's not going to work. So instead of going through the process and canceling and actually taking the square root, the negative means that I have a no solution. So I'll write no solution. And if I were to graph this graph would not have any x-intercepts. So an example of what that would look like, a quadratic equation with no solution might be something like this. Our parabola is not intersecting our x-axis at all, and so therefore there are no solutions to the graph. And when that occurs, if you were to work out the equation, you would end up getting something like we did right here, with x squared is equal to negative 4, take the square root of both sides, and you see that you'd have a negative underneath the radical. So in this case, example 3 is going to be a no solution.